Now I've lifted this straight out of your textbook. This is a sort of a step-by-step guide to how you can work out which of the trigonometric ratios you need to use. So let's just read through it. The difficulty with any trigonometric problem is knowing which ratio to use to solve it. To find the length of the side marked x in this triangle, follow the steps below. So first of all, let's just make sure we've got something where we can do this. So step 1, identify what information you have been given and what you need to find. In this case, x is the opposite angle. So that's one of my sides is the opposite, and that's the most important one to consider. And the angle and 16 centimetres are the other two things I have. Now the 16 centimetres is the hypotenuse. So step 2 is deciding which of the ratios I need to use. Opposite and hypotenuse mean I need to use sine. Okay, so they say, remember sine theta is O over H. That's not a problem, we know that because of SOHCAHTOA. Put in the numbers and the letters as we were doing previously. Sine 37 is x over 16. Rearrange, solve the equation, step 5, and then the given answer to an appropriate degree of accuracy. So from my previous videos, hopefully you've sort of been doing this anyway, but as it was always sine, always cos and always tan, it was these first sort of couple of steps that maybe you didn't need to pay much attention to. That is going to be critical in this exercise. So first of all, let's just check what we got. Find the length of the side marked x in this triangle. Well, the angle's 50 degrees. The side x is the adjacent side, and the other side given is the hypotenuse. And I wrote A over H because I had sort of spotted that already. Maybe once, first of all, have a look, make that conscious decision, and then when you're writing down which of the ratios you think it is, just check again to be 100% sure that you've got the right one. So adjacent and hypotenuse is the CAH, car, SOHCAHTOA. So I've got cos theta is A over H. It's now just popping in the values. So I've got cos 50 equals the adjacent, which is x, over the hypotenuse, which is 7. So x will equal 7 cos 50. And now it's calculator time. 7 cos 50 is 4.499513 ... So what degree of accuracy? Well, I'm going to do it to 3 significant figures, but I'm just going to be a bit careful because this rounding doesn't look great. I'm going to draw the imaginary line in my head after my 3 significant figures, 4.49 being the first 3, and then I'm going to round from there. So the 9 after the red line is going to round up the next 9 to a 10, which means actually that's then going to round up the next digit as well from a 4 to a 5. So I end up with 4.50, but that is to 3 significant figures. Okay, so 4.50. That's, then I do my quick check. Hypotenuse is 7, angle is 50, yep, 4.5 centimetres looks pretty good. Example 16, find the angle marked x in this triangle. Well, that's different. Find the angle marked x. Well, previously we've always been working out side lengths. We've worked with the angle, but we haven't had to calculate it. So this will take just a bit of time to explain. But first of all, we do exactly the same process. This is the angle we're working with. Here's the opposite. Here's the hypotenuse. So the first thing I need to work out is that I'm working with sine. So I have sine theta equals the opposite over the hypotenuse. Now I feed in the information, and I have sine x is the angle. That equals 9 over 15. Okay, so sine x equals 9 over 15. And this is now the stage where it's slightly different. When we have the angle, we just type into our calculator sine 30, sine 50, cos 26, whatever it may be. Now that we're trying to calculate the angle, you don't divide by sine or divide by tan. What we do is this inverse function of sine x or cos x or tan x, which is sine minus 1. Actually, strictly speaking, that's not very good maths, okay? But we won't go into the details. It's perfectly acceptable for you to write x equals sine minus 1 9 over 15, as you did in one of the previous exercises when you were working things out. When you were finding the angle, you did sine minus 1, and then we would go from there. So second function, sine, open a bracket, fraction button, 9 over 15, close the bracket, press equals, and that tells us that it's 36.869897 ... So I'll do that to one decimal place and say that's 36.9 degrees. Okay, so that's different. That's finding the angle. But what do we do? First of all, we worked out which ratio we needed, sine, cos or tan, in this case sine. Then we wrote out the sine ratio. Sine theta is opposite over hypotenuse. Pop in the information you've got with side lengths and angle if it's given. In this case, we weren't given the angle, we're just given it as x. But we pop it in as we have been. The difference is when we're working out x, we do that sine minus 1 because we're trying to find the angle. So let's have a look at another one. This time find the angle marked x in this triangle. Okay, well the triangle's been sort of rotated a bit, but we can see from the right angle where the right angle is where the hypotenuse is. Of course, the hypotenuse is always opposite the right angle, and we're not working with that. So that instantly tells me that it must be tan, because tan is opposite and adjacent. Of course, I could also say, well, that's the opposite side, and this is the side that's touching the right angle and my angle, so that means that must be the adjacent. But I'm going to go through the same process. Tan theta equals opposite over adjacent. Feed in the information I've got. Tan, the angle is x, the opposite is 12, and I need to be careful about that, over the adjacent, which is 7. And so x will equal tan to the minus 1 of 12 divided by 7. And then calculator, second function, tan, open a bracket, 12 divided by 7, close a bracket, press equals, and that tells me that x is 59.743, so we'll have 59.7 degrees to one decimal place, or 3 sig figs, they're both the same for this one. 59.7 degrees, and we have calculated the angle. So, next exercise is up and running. Get cracking. Any problems, issues, let me know, particularly with finding the angle questions. The first few are just working out a side length, then it's finding the angle. When you get to that, if you are struggling, give me a shout and I'll happily come and give you a hand. Good luck!